Hello to all my viewers. This is Dr. Dhaval Maheta, and today we will understand how to split the dataset using probabilistic neural network predictor in KNIME. A probabilistic neural network is a type of artificial neural network that is used for classification and pattern recognition tasks. PNNs are used on the Bayes theorem of the probability, and they work by estimating the probability distribution of the input data. PNN consists of four layers: an input layer, a pattern layer, a summation layer, and the output layer. The input layer receives the data and the pattern layer converts it into the probability density function by calculating the distance between the input data and the prototypes in the pattern layer. The summation layer combines the PDFs and, and it calculates the posterior probabilities, which are then passed to the output layer for the classification. PNNs have several advantages over other types of neural networks, such as their ability to handle the non-linearly separable data, their fast training time, and their ability to classify the data with high accuracy. However, they are not as widely used as other types of neural network because they can be computationally expensive and they require large amount of memory to store the prototypes. So let's see how we can run PNN in KNIME. So for this, we'll go in the KNIME Analytics platform. First of all, I'll activate the input output node from here. I'll double click on it so that I can browse the dataset which is in the CSV folder. Connect Heart1, open, click OK. See, it is in CSV format. The dataset is in CSV format. Execute. Now, activate the column filter from here so that we can select only those variables which are necessary in our model. Execute. Right click on it and you can see the filter table. Next thing which I want to activate is the color manager. Right click on it and configure. So you can see if a person is having a heart disease, it will be represented by red color, and if it is not, then green color. Click OK. Right click on it and execute. Then I will normalize it. I'll normalize all the variables using mean max normalization. Configure. Click OK. Right click on it and execute. Now I'll activate the PNN learner. Right click on it, configure, make sure that the target column is. Now here we will have to change something because it is showing all the variables. So let us go here in the column filter, configure. We will have to remove all other variables and only include age, resting blood pressure, cholesterol, maximum hours of exercise, and heart disease. Click OK and run it again. And again right click on it and configure. Okay, so our heart disease is a target variable. Click OK. Right click on it and execute. Now activate the PNN predictor. Disconnect this line from here. And you can join this normalizer directly. But before that, let us introduce the partitioning also. So where the partitioning will be introduced, I'll show you that. Disconnect this line from here. The partitioning will be introduced here. So connect normalizer with the partitioning. Right click on it, configure. 80% will go for the training purpose and remaining 20% will go for testing. And we will be using stratified sampling according to the heart disease. Right click on it and execute. Now 80% of the data will go for learning and remaining 20% will go for testing. This predictor will get its learning from here. Execute. Now right click on it and you can see the predicted data. So this is the prediction done according to the algorithm and this is the original data. Now we want to check that how well our prediction accuracy is. So for this, we will have to understand the concept of confusion matrix. Say for example, if a person is having a COVID and there is a kit to detect that the person is having a COVID or not. And if the kit detects that yes, the person is having a COVID, so this is a success for us as the kit is working successfully here. A person is normal and the kit detected that the person is normal. This is also success for us. So 114 plus 50, 164 are correctly classified cases. We want more and more such cases where the algorithm is able to classify the data appropriately. The misclassification has happened here. The person is normal, but the kit detected that the person is having a COVID. 6 such misclassified cases are there, and a patient is having a COVID, but the kit detected that a patient is normal. So this is also a misclassification. So 22 plus 6, 28 are misclassified cases. Let's see how we can check the classification accuracy of PNN. I'll activate the scorer from here. Right click on it, configure. I'll activate the heart disease from here, click OK. Right click on it and execute. Again, right click on it and you can see the confusion matrix. So 51, a person is not having a heart disease and the algorithm also predicted correctly. 51 such cases are there. A person is having a heart disease and the algorithm predicted correctly. So 83, 51 plus 83, 134 are correctly classified cases. Misclassification happened in 19 plus 31, 50 cases. Our classification accuracy is 72.82%. So this is a way you can split the data in KNIME. For more videos on KNIME, you can subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I have already uploaded many videos on KNIME.